Good afternoon or good morning, everybody. Welcome to another space on the Gensyn X account. Today we've got a fantastic one with Gabriel, Andrade, and Semih. Gabe, we've spoken to several times before. I believe, Semih, it is your first time up on a Twitter space. Is that correct?
Yep. Can you hear me?
Absolutely, can hear you fine. And Gabe, how's your mic?
Test, test.
Testing marvelous.
All good? Cool.
Fantastic. Thanks very much, guys, for joining me today. I know you're both
Thanks for having us.
super busy with everything that's going on at the moment. We've got an awful lot happening in the next few weeks and in the previous few weeks. So I know exactly how much how hard you guys have been working. So this is fantastic. Sammy, I think we just had a little bit of
Yeah.
echo on or feedback on your mic. There we go. Very good. Excellent. Also, thank you everybody out in the audience there who's given up some time today to come and hang out with us. Today we've got quite an interesting topic. There's been some posts and some papers and things that have come out recently that are quite relevant to things that we are doing or have been doing. And so you can see the title of the space is that we were early. We're talking today about swarm, systems training, and the future of collaborative AI. And I can't think of two better people to speak to about that than the ones we have here today. So early on, Gensyn was obviously working quite deeply in swarm-based reinforcement learning. Also released code assist and block assist related to assistance training, and that all moves into what Semih's been working on recently around collaborative AI. So if I can get each of you just to give a very, very quick intro of yourselves and what you're working on at the moment, and we'll start with you, Gabe.
Sure. Thanks again, Xavier, for making all this happen, or rather, Xavier. Apologies. And yeah, so I think a lot of the folks here know me, but I'm Gabe or Gab or Gabriel, whatever y'all prefer. I'm a researcher here who I work on a lot of things. In the past, I did a lot of multi-agent ML, RL sort of topics. I always have this game theoretic lean to things. Though more recently, I've been focusing a lot on market mechanisms and incentive problems and just more pure economic econ CS sort of problems. So I've taken a little bit of a pivot, but it's still near and dear to my heart, and I follow it as much as I can.
Fantastic, thank you. Semih.
Hi. So, is there still echo happening, or am I good?
No, you're fine.
Okay, cool. Yeah, thanks. Yeah, so I joined Gensyn in August, and before that, I was a postdoc at University of Illinois Urbana-Champaign, and then 1 year before that, I got my PhD from University of Maryland, College Park. And we do have a common interest in game theory with Gabe. So during my PhD and postdoc, I worked on like multi-agent systems, learning in multi-agent systems, which involve a lot of game theory. Um, yeah, and I also work on reinforcement learning, dynamical systems. Yeah.
Brilliant. Excellent. Thank you for coming and joining us. Gabe, I might start with you. There was some conversations we were having earlier in the week and last week based on some posts on X and some articles that were released. If you could humor me, just give a little bit of a wrap of what those conversations were about, what those posts were referring to.
Yeah, so essentially, Meta recently put out this paper with a bunch of folks on this concept they call a neural computer. And in this paper is a bit weird in the sense that it really is more so posing an idea and giving some preliminary results and a little bit of a taste of what this is going to look like, and then charting out the big research roadmap for the future. And I think it's a really cool concept, but it's just in its infancy, right? So I do encourage people to check this out and play around with stuff. I think it's really neat, but just temper expectations on what you'll get, because again, very much in its infancy. But what's going on with these neural computers is the basic idea of uh, can you basically replace all the interfaces in a computer, the input output, the memory management, the just everything going on in the computer with a model itself? In some sense, the model becomes the replacement for your GUI and for your command line. It's the thing between you and the hardware, and everything else in this vision gets replaced by this model. Um, that's the basic idea, and they put out these a little demo that like shows how it might look for a GUI and for a command line interface. They use like a vision text model to then generate the next frame essentially. And yeah, the idea is like you're basically interacting directly with the model. The model then churns in the background, manages the hardware, and then puts something in front of you again. Now, why is this? Why are we even talking about this today? Well, what's the whole point? To tie it back all together, this looks a lot like tool mediation games and assistance games. They're almost like cousins, and they live in the same ball field in a very odd way. Um, and there's a lot of like weird thoughts to have on this, but I'll try to stay focused for a second here. I'm not gonna too lost in the sauce. But basically, the connection with this tool mediation games and with assistance games is you have this model that lives in the middle between you and your hardware. It needs to manage all this hardware, everything that's going on in the background of your computer. And it has to do this by guessing your objective based and your intentions based on how you interact with your mouse, your keyboard, or in whatever future this lives in, whatever modality makes sense to interact with computers. Maybe it's like where you're an eye tracker. I don't know. There's a lot of wild things we'll have talked about in the past that now start to make a lot more sense as far as how you interact with a computer when you start thinking it from this paradigm. But yeah, so you basically have this model that's in the middle. It's trying to take your intention and infer your intention and your objectives from direct action in essentially a stream of actions, and then turn this into something that it then puts back in front of you in the way that matches your intention. In assistance games, rather in tool mediation games that we did in Code Assist, you have something very similar, which is you're interacting with an environment. A model sits in the middle and kind of watches what you're doing, tries to infer your your objectives and your intentions, and then route this to the correct tool. Mm-hmm. So you can see that there's a very similar flavor here. And I imagine that in the realist, like in the future versions of these neural computers, at least in some interim version, you would still need something like a tool mediation game happening, just because it doesn't really make sense for a model to do math when you can just call a calculator, for example, right? So the model might want to go do something that it doesn't need to do itself. But yeah, that's I think that I'll stop there before I keep going and meander for the next hour. But
no, that was
any
great.
questions from there?
That was fantastic. Exactly what I was looking for, and tracing that lineage through the work that Jens has been doing, and the work that these other quite large companies are now coming to. Semih, I'll bring you in.
Sorry, one last thing I forgot to mention here. That's not to interject, but just to throw this in there. What I think is also really interesting with this things you mentioned, the other large companies, is where everyone else is kind of looking at RLHF, and essentially you have this interface that's human agent, computer, and world. What's happening in both paradigms of neural computers and in assistance games and in tool mediation games is it's basically human and agent are directly touching computer and the world, right? And so it's changing this pipeline in a really interesting way, and it changes the way that you do alignment and the sort of like you have this how you align the model and what it's trying to do in a really unique way that I think is closer to what we want ultimately. And it solves a lot of the problems we currently have, which is like slop that becomes overwhelming and hard to even judge quality of, because at every step you're judging its quality rather than judging it after it's produced 20 pages of nothing. Mm-hmm. But yeah, so with that, I'll pass on. But okay. Sorry, you reminded me it's a big company.
No, that's fine. Keep that thought though. Those last few thoughts, I think, will directly relate to when we later in talk when we bring it all back together as well. Semih, if you unmute and just give us a bit of an explanation of the work you've been doing. You mentioned to me earlier on that collaborative post-training is your focus at the moment. Can you explain that so that people who don't have much experience with it could get a grasp?
Yep, for sure. Yeah, I'd love to. So, I think to put that into like perspective of what we have done, RL Swarm is our kind of like main product that was related to collaborative post-training. So let me like start with that and then I guess go towards what I am working on currently.
Absolutely.
So our goal with RL Swarm, at least my perspective on it, was to transfer knowledge or capabilities between models. That was essentially the goal. So, for example, if Gabe and I have models that are good at different tasks, we want to do some kind of magic, you know, and we both want to end up with a model or models that are good at both tasks. And like moving along this perspective, more diversity in expertise we have, like more expert models in like different expertise we have, the better. And to facilitate this, like an effective approach is to have like a fully decentralized network where anyone can join with their own model. And this way we can, you know, represent their preferences or the expertise of their models in the final trained models.
Mhm.
And that was what kind of led to RL Swarm. You know, it's like a network where anyone can join with their model and be represented, you know, in the final trained model or models. And this is, yeah, like a very intriguing thing from both a product and academic perspective.
It's possible for anybody to contribute to the final product, the final trained model, by bringing their own and its own specific profile.
Exactly. Yeah. I mean, that's like one of the key components. Like you want everybody to be represented. You know, their needs or their expertise to be presented. And well, this is a very challenging task. So post-training for models have an awful lot of similarities with how humans learn. So think of this example where, you know, if like I'm an expert in quantum mechanics and I'm trying to teach someone who has never heard of quantum mechanics, you know, to reason on
Mhm.
this domain. How am I going to do that? Like that's, you know, or you can like literally replace human with model in the sentence that I made, and this is like, you know, how like it tells.
Nope. We may have lost Semih there for a minute, or have we lost me?
No, we lost Semih. He was cooking too hard, I think.
He was. He was getting right into it. That's unfortunate. We'll see if we can get him to drop out and join again. Gabe, why don't you pick it up there? We'll get deeper into the work Semih's been doing shortly, but just in terms of what he had spoken about so far, you can pull that back to your conversation earlier and the thoughts you were beginning to have on those larger companies.
Yeah. So okay. So there's a few elements here that I think is really interesting, and I think it's where this is gonna hopefully this will be a good segue when Semi comes back here. But essentially, when you start to imagine this world where you have this model in the middle, you no longer need this like carefully orchestrated set of of compilers and kernels and so on living in the middle that that are pretty rigid in how they operate. I mean, they can do a lot of things, but how they do how they actually execute those things is pretty rigid. The model can be very flexible. So you can think of it as essentially allowing us to tap into like a raw sea of information, and the model acts as essentially a filter that gives it back in the to mirror your intent. What Semih's work does, it kind of expands this in a really neat way. So it takes this vision of the neural computer, and you can imagine this world where not only is it interacting with your computer, your hardware, the thing that's directly near you, but it's also incorporating and inferring your intent while taking from other people's expertise, other people's intent, what's worked for them, etc. You can imagine this very cool sort of interface that arises. Um, and yeah, I think that becomes a very, very fascinating object to imagine is like what kind of information streams would you tap into, and what does this unlock? You can imagine a world where no longer is there just like a specific UI for a website. Everyone's UI is personalized to them, and how they like to interact, how their intent likes to do things. Um, yeah, one example that comes to mind immediately is I don't know if folks have seen the Japanese internet. It looks very different from the internet that we tend to use. But like you can imagine just two people, one grew up with that internet versus the internet that we use now. Here would just like their GUI for the same website would just look totally different, which is very very interesting. And for the same app would look very different. And it just unlocks this very sci-fi-esque interesting thing. But
I'm wondering how much time you spent on the Japanese internet. Yeah. Um, but,
not much, but it's fascinating.
brilliant. Now, there was a good question. We're using some terms of collaborative post-training, and once we get Semih back online, he's having a couple of issues here. Collaborative post-training, do you have a simple way of explaining how that's different, and why it's different to post-training in general?
Compared like vanilla post training, I suppose.
Yes, yeah.
Yeah, Semih will definitely have the more insightful answer to this, but I'll give you my take on it. I think where it gets really maybe this isn't actually intuitive, but I'll give it to you how I think about it, which is in humans, you often think there's something called if you I don't know if folks know the philosopher Wittgenstein. He has this idea of private language theory. Okay, and in private language theory, the basic concept is if I say an abstract word, let's say love or I miss someone, we all kind of know what we mean, but when I say it's the word love, for example, it probably means something slightly different to me than what it means to you and every other person. So we each have our own private language, but we can still communicate with each other, but really you have an approximation of what I'm trying to convey. And with collaborative post-training, you get something similar. In vanilla post-training, all the reasoning, all the thoughts are coming from the same model. Mm-hmm. Therefore, when you try to train and calibrate things on the reasoning, you know that there's like this foundational steady ground. You know, the earth isn't shifting underneath you as you move, as you literally rewire your own brain in the post-training process.
Right.
With collaborative post-training, you get now you have there's subtle differences in a reasoning trace between the two models or between many models. So when you're trying to integrate them together, this can, with enough little changes, lead to something where like the word love in that example I gave gets for some reason tied to like, I don't know, the word aardvark. And so love means aardvark to you for some reason after enough of these little changes, these little approximation errors adding on to one another. And I think that's where the really difficulty is always keeping it kind of steady and calibrated. The possibilities are obviously endless, and the efficiency gains you get by being able to parallelize at that scale, explore that massively are great. But that is the difficulty: is that you basically you always want to exploit what you've explored, and exploiting often leads to this weird this weird mismatch at the time. I think we have Semih back to actually give you the real answer.
We do, I think. Semih.
Hello. Can you hear me?
Yeah, fantastic. Gabe, I'm going to throw this one on to you. If you want to ask Semih the next appropriate question to draw out some insights around the topics that you were so eloquently explaining to us.
Yeah, I guess my first question would be, Semih, do you agree with that take? Like, what makes in your view, what makes collaborative post training so different from vanilla single agent post training?
Okay, first of all, yeah, like I've always seen like people having issues with the X space. Now
Yeah.
I know how it is like to feel like it's weird. Like I didn't even realize that I was gone. But
You're,
anyways,
you're not an X space expert until you've been rugged a couple of times by X.
yeah. This is great. Like now I know. Now I know. Anyway, so yeah, I think one major benefit of like multi-agent training is I don't know like how um, deep I was able to go before I cut off, but it's like the diversity and expertise. That's like I believe one of the major upsides.
Hmm.
And a second thing I would say, which also has like an orthogonal direction, is multi-agent workflows. So I don't know if you guys have ever played with it, but you can like if you're using Cloud Code, you can spawn like multiple agents and like orchestrate them to do something,
Right.
or most of the research tools, like deep research tools of like Anthropic or OpenAI also have multi-agent workflows.
Hmm.
It's essentially like an orchestrator agent spawns or decides to spawn like whatever sub-agent is needed, and that sub-agent is usually like more specialized in a certain thing, and is like a smaller model. So it can do things like much cheaper and in a much more accurate way as well. And since this is a multi-agent system, like training these make most sense in a multi-agent setting. So I think that's like if you want to build a multi-agent system, which people are very interested in, it's very hyped, and it works well, you need a multi-agent training framework.
Semih, let me ask, why do you think this isn't the standard yet? And do you think it's bridgeable? Do you think that there's the fact that it isn't the standard, if it does, even if it works a little bit now, do you think it will lead to problems later? Like, what's your take on this?
I think it is gaining more traction. I think it is not like, I guess, the main kind of inference architecture, because it can end up being more costly for at least simple tasks. Like if I'm just like asking the model to rephrase like an email, you know, then I don't need like multiple agents like going all over and like generating things in parallel. That would be just like a waste of tokens.
Well, I
Um,
do. You haven't seen my emails.
so overall, I feel like it really depends on the use case. Like I would say that kind of like inference engines are already like the standard for example, deep research tasks. Like if you go to deep research in Claude or ChatGPT, like they do spawn like multiple agents and they use like a multi-agent workflow. Uh, but yeah, like it's not the default because it's often not required unless you are Xavier writing an email.
Absolutely. What about with things like deep research, those kind of examples you were giving? In my mind, that's multiple agents doing various tasks in order to get to the task quicker or to get a better result. What about agents working with each other in this kind of collaborative environment in order to review and correct? Is that kind of feedback loop part of the structure you were talking about?
Yep, exactly. And that is exactly like the research that I'm working on at the moment. Um, so say that, you have like a multi-agent system, an orchestrator and like multiple sub-agents. You want them to work efficiently. And, what this comprises of is when the sub-agents, finish their tasks and like go back to the orchestrator. They present some results, that might be correct, that might be incorrect, it might need some like improvement, whatever. The message is the orchestrator might need to call the subagent again or like reprompt to it, saying that, well, you did this, but I actually needed that. So let's go ahead and fix that. So what I'm working on right now is making that, how do you say, like desired behavior for the subagents to come about without the orchestrator telling them explicitly to do so. So it is as if like they have gone through this process of, doing like a research task many, many times. And during these trials, they have realized that like, oh, if the subagent does this, then that gives a better result. So we distill that context back into the orchestrator on how to give feedback, or to the subagent on, what to do. We distill that information back to those agents so that like without explicitly reprompting each other or like doing it all over again, they would from the beginning do the desired behavior.
So we're saving time, saving effort, saving tokens, and getting better results.
Yep, exactly.
Brilliant. I'm going to point this Gabe, but either of you can jump in and argue amongst each other. You both have much wider and more complete knowledge than I do of all of the ins and outs of all of these systems. I feel like we've almost been talking about 3 or 4 different topics. Gabe, if you want to start off, if you can pull all those together for me, and along the history of Gensyn as well, it'd be fantastic.
I guess to make sure I don't end up, I end up at the destination that we have planned here. What are the 4 topics you think we're talking about?
Well, there's Semih's work on the collaborative post-training orchestrator agents and efficiencies there, and then I'm thinking back to the original RL Swarm being a, as we know, the Swarm where all of the agents feed off each other in a way. And I have it stuck in my mind of Code Assist, how the network of Code Assist agents was intended to increase its knowledge as everybody connected and everybody did their own sort of work.
Okay, thank you. Yeah, that helps. So they are all related. It's hard, right? So this is kind of the curse of talking to a researcher. How we make progress, essentially, you take this big thing and then you have to kind of chop the fat off until you get your core question so that it's tractable. Because if you try to chew off the whole thing at once, you actually can't make progress, you can't measure things, you basically are always like, you're never sure what's the thing that got you the gain or what made you lose something. So that's essentially the trick to research. So with that said, they are all related. They aren't related today or at this moment in the strict sense of our work. They are on the conceptual side and on kind of once we get to a certain point, what's the next question to move on to next. So with that little preamble going on, how I see it, where the connective tissue comes together is you have something like Code Assist, where you're just living your life, you're doing whatever you want. You have some agent that's just in the background getting this raw stream of information that you're producing. It infers your intent, your objectives. It picks tools. Those tools might exist on something like RL Swarm. Now, on RL Swarm, these tools are constantly buzzing. They're generating outputs, taking in inputs. They broadcast them out, or at least send them to some subset of other agents. Here's where that collaborative sort of ecosystem, like Semih brought up, might live, where you might say you might interact with your agent, and so locally you're looking up something that's related to the weather. Your agent goes, "Oh, there's some weather type question going on here." It says, "Hey, you're based in Germany, in Munich specifically," and it then shoots off to the swarm some kind of some request of like, "Hey, I need information about the weather. I need a very good forecast about the weather in Munich over the next week." The other agents in the swarm all start buzzing. They go look at different data sources. They report back. And you go this back and forth, right? And then it collects that information about the weather. You've still had intentions as you progress. It fires off some other requests. Now maybe it's about the best tourist destinations in Munich, or best kebab place. I don't know. And it just keeps redoing this sort of thing. It gets verified by others in the swarm while time is going on. And by the time you actually need the information that it's inferring your intent from, that would be when it actually it presents it to you in some way. But it's trying to always be one or two steps ahead of you, shooting it off the swarm, letting the swarm do work. And this is often repeatable, right? If you think about that like weather example, you're probably not the only person who needs to know about weather in Munich next week. There's probably one or two other people in Munich who care about weather. And yeah, that's the high level. But it doesn't reflect in research itself, in my opinion. But yeah, Semih, do you disagree with any point of that, or like, do you have a different vision?
No,
in
I
mind?
totally agree with everything that you said. I also have, I guess, like a extra layer that I can mention, which is like personalization.
Yes.
Yeah, like all of this stuff that I mean, with RL Swarm, like without like diversity, you are not really gaining anything. Like without diversity,
Right.
it just becomes like the same, like copies of the same model, just like sharing information. I mean, you do gain, I guess, compute efficiency rather than only you generating things that you learned from. You have a bunch of people sharing what they have generated, but that really doesn't contribute to your overall expertise. It just like means that you learn like more efficiently, but you don't learn more.
Becomes homogeneous.
And so you do need diversity, and block assist, like the assist type of work that we have done, that is for personalization. That makes the model personalized for you. So just like this, having agency over the model that you're using, that you're putting into the network, and having that personalized for you is like a common theme in all of the work that we're doing.
Yeah, and that's a really good point about personalization, where like this thing that lives between you and the swarm, it also is able to process that like whatever modality the swarm or all these agents that are buzzing present to you, right? If you just got this very complex presentation about like you asked about like there's something about the weather you care about, and it gives you some charts that you can't read unless you're a meteorologist, that's not helpful. Whereas your assist sort of capabilities, whatever agent lives between you and that sort of floodgate of information that's always coming, that's able to kind of filter out, kind of compress it, and put it in a format that you need for whatever you want. And then there's another thing to mention in terms of this personalization piece, which I think is really key. And I think this is where the like having just one giant model will eventually hit a cap. There's actually an impossibility result in alignment, where if you want in assistant alignment, where the impossibility result is something along the following lines. Given two models with equal capabilities, if one model is meant to serve many humans, then it is impossible for that model to serve, and it's adapting to all those humans, it's impossible for that model to serve all humans with equal quality. It must degrade quality with someone to make quality better for someone else, assuming that people aren't themselves homogeneous that they're serving, right? So that would mean that there can't be one giant model that serves all humans on Earth with equal levels of efficiency and equal levels of alignment to what they need. And this is where having the personalization element and the swarm type element um, is able to break those assumptions and make this impossibility theorem not basically apply. But yeah.
Brilliant, thank you. Couple of really quick questions before we start to wind up. We did begin speaking of neurocomputers and Meta and the pieces that their articles and papers are referencing in the relationship to what Gensyn's been doing in the past and currently. Why do you think, Semih or Gabe, why do you think these other companies are talking about it now? Like, what's changed in the industry that other people are having related kind of conversations?
I can give it a stab. I think one of the main reasons was like with the advancements in tool use, like now that models can do like internet search, I don't know, like command line, like terminal code executions, like just like a bunch of other stuff too. They became like a lot more able to do like to interact with the external world, and that really helps with the efficiency, like the efficacy of multi-agent workflows.
Right.
I think, yeah, with like, like tool use, the external world interactions increase, like this type of work will become more and more prevalent. And I think it is going to keep gaining traction as smaller models also become better. So one of the reasons why Gensyn was early and why there, a second reason why these other companies are focusing more on these is because, small models are becoming more capable. So now, if you have a task, like a coding task, where you can just like hand it off to like a 7B model. Like now the 7B model does a pretty decent job writing that, I don't know, like a bubble sort algorithm for you or whatever. I think with the small models becoming more and more usable for daily tasks, this kind of like personalization and collaborative, like multi-agent workflows are going to become more prevalent.
Yeah, it's what Sammy said. Just rephrasing it in a more like economic sort of perspective would be like my angle would be like there's diminishing returns for doing the thing that they were doing before, which is just bigger, 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 central, central, central.
Right.
Whereas the ability of these small models is getting bigger. The time cost of running them is much lower, and their reliability is just always improving. So now, once that frontier, the frontier of the big model, the monolith, becomes really hard to make progress on. It becomes more natural to look elsewhere and make progress quicker because they're in an arms race with one another at the end of the day to show we're faster, we're making cooler, bigger innovation. You asked a question about neural computers. So Anthropic, OpenAI, they're doing this sort of multi-agent workflows for research, et cetera, for sure, but they're not touching neural computers. Meta is touching neural computers. If you ask why, I mean, this is my jaded guess. I would also guess it's because they're not in the competition really when it comes to the monolithic models and these streamlined things. So they're trying to basically take the new angle rather than chasing that dragon and trying to catch up. They're pivoting to sort of an orthogonal approach, which is also exciting and new, and it's a bit of a longer shot sort of approach. Interestingly, it's Meta's taking like what small companies like Gensyn need to do always, which is kind of interesting to see at their scale. But yeah.
Very interesting, absolutely. Now the final question, the big one, the fun one. In your wildest imagination, where do these processes, particularly I think the collaborative element is is what I'm interested in. Where do you see this taking us? What is in the future in some number of years? Although everything goes so fast, it'll probably be next year.
I mean, I would love to see like just like people giving out compute, running like local models for agentic workflows and contributing to like resolution of like a major task. I mean, this can be like you know, like something in like medicine, you know, trying to find like a protein sequencer or something like that. That would maybe, you know, give rise to an important vaccine or something. And that would require like a major compute. And I would love to, you know, yeah, like that, like multi-agentic workflow plus, you know, people giving out compute to reach that scale be a reality. That's kind of like a, you know, like a big major accomplishment, I would say would be, that would be, but in like a smaller scale that, you know, we can definitely, you know, reach, not, you know, with not that much effort would be, like smaller scale problems, less compute, but still having like, a decent, inference engine where, people can contribute with their compute. People using it would incentivize this compute, and then yeah, you would have like this decentralized network of you know inference, this decentralized inference engine where you can solve like difficult problems through multi-agent workflows.
Fantastic, and I agree. The medical research is such a incredibly exciting area for all of this to produce some massive results in, I think. Gabe, where's your mind going?
Yeah, so I'll preface saying like I kind of see two possibilities here. One is where we don't lean into this sort of open, sort of permissionless, more decentralized approach, where basically if we do lean into that, I think I see a world kind of what Semih described, right? We're always doing medical research in the background. There's like you're living your life with basically like, if anyone's played that game Mega Man Battle Network, your own little net navi that goes and does things for you. And there's this whole virtual world essentially happening in the background that supports the physical infrastructure and the physical economy and really empowers it. If we don't go down that route, I do see a pretty dystopian manifestation of this, which, yeah. Anyway,
talk about Skynet on one of my spaces.
It's not even Skynet. I think that Skynet is giving it to each. I think that the risk is honestly like the failure of. It's a lack of privacy. It's like it's not. Maybe it's a Skynet type thing, but it's this lack of like. It's that how every cafe looks beige, but for intelligence and information, and information generation, right? Everything homogenizes and serves just a few people, that type of thing. But yeah, where I see this going, where I hope it goes, is kind of what Semih said. It's something. There's always this like this mirror world essentially where compute is always buzzing. There's sovereign agents even that are helping facilitate this. They can provision their own compute. They can provision their own information. Anything you want to know basically just gets pushed back into this virtual world. And I talk about this virtual world, this mirror world, but what really, in today's terms, we'd probably call it something like a world model. It's something that's always simulating and trying to forecast essentially any facet of the world anyone cares about. This includes medical research. This includes education. This includes even how you should manage your day, right? Not directly, right? It's not like this whole thing is serving just you. Rather, it produces signals, and your personalized interface to this mirror world is what harnesses those signals and transforms it into something that suits you and serves you as an individual and helps you flourish. But that's kind of the world I envision and hope to see. It's something where everyone can kind of do their own thing, and in the background there's this very, very, very rich ecosystem of information just going back and forth, buzzing and solving real problems, generating signals that can be useful, and sustaining itself.
Fascinating. Also, a very interesting and exciting possibility. I certainly hope we don't go down the beige possibility like you. But well, we've run on a little while now. Thank you both so much for joining me. That was a really entertaining chat. I quite enjoyed that. Everybody out there, once again, thank you for joining us. Always appreciate you spending your time here with us. And make sure you jump into the Discord to ask any further questions, and we'll catch up with you in there. Gabe, Semih, enjoy your weekends, and we'll speak to you soon.
Thanks, Xavier. Thanks, Semih. And thanks everyone for coming.
Thank you.